Good evening, everyone. We'll just wait for a couple of minutes before we start. I think the teachers are just getting back home and the students as well from school. So we'll just give them a few more minutes before we start.
Ms. Jan, we can start now.
Yes, sir. Good evening, everyone. So just to welcome you all on this cold November day. At least it's cold in Delhi. I hope it's warmer everywhere else. Thankfully, the sun is shining, so which means that the pollution is a little lesser. So, good evening to all the teachers and the students who are joining us as well, our colleagues as well from CSIR-NIScPR, and especially Dr. Shruti. Welcome, everybody, to the 8th webinar in our series of Science 101. So, just to let everyone know that, as usual and as our regular practice, this webinar is being recorded and is simultaneously also being streamed live on USO's YouTube channel. I hope all the students have been provided the links and they are joining us through the live YouTube link. So, just some housekeeping items before we begin. The mic, video, and chat for everyone is currently disabled, and a chat shall be opened up during our question and answer session, which will be towards the end of the webinar. Now, going and giving you a little overview about the partners. This webinar series is being conducted for since April, in fact, and United Schools Organization of India, which is the organization that I represent, was established in 1951. And it is our aim to advance the social, cultural, and moral standard of schools in India to global levels. We conduct several extracurricular tests, seminars, conferences, competitions, campaigns. We should add webinars to that as well, which is not, of course, in the write-up, but we have been doing that for the last several months. And all of these activities are on a national platform. Our partners with this are esteemed partners, and we are so happy that we were able to collaborate for this wonderful activity, is CSIR-NIScPR. CSIR stands for the Council of Scientific and Industrial Research. They were established by the government of India in September of 1942. We are the largest research and development organization in India. And NISPR, formerly called NIScPR, which is the National Institute of Science, Communication and Policy Research, is located in New Delhi. Their offices are right next door to ours, and they are the Information Science Institute of India, founded in 2002. Mr. C.B. Singh, who is joining us, heads the division, which is the Jigyasa division at CSIR-NISpR. May I invite Singh sir, if I can request you to say a few words about the wonderful work that you're doing.
Thank you. It feels so nice to have the students, to have the teachers, and as well the resource person, Dr. Shruti. A warm welcome to this webinar series. And I hope, Dr. Shruti, it appears that it's quite comfortable weather there at the Mysuru. Is it so?
Yeah, definitely.
Yeah. See, we are here in Delhi, particularly in Delhi. It's so cold in the morning and in the evening. And the afternoon, it's a bit comfortable because of the lesser pollution here recently and the bright sunshine. So it's a very good temperature if you can consider it a very good weather with the blue sky here in Delhi nowadays. So let me first welcome a warm welcome to the resource person, Dr. Shruti Pandey from CFTRI, Central Food Technological Research Institute, which is one of the CSIR lab, to the USO and all the team from the USO, and as well to the a warm welcome to the Jigyasa team who is participating into it, and the teachers and students who are joining from all over India. A warm welcome to you as well. Let me this time, it's unusual that we tell you all about what CSIR is and what NISpR is, and what are the different mandates of the Jigyasa common program. So I'll reiterate again that first I'll tell you about the CSIR. So CSIR is a Council of Scientific and Industrial Research for the benefit of the students and the teachers. And it has 37 labs spread across pan-India. So these labs, they are carrying out the research in their regional areas. And this research is particularly in the industrial area. So in the basic sciences, the research is taking place for the industries, and for all the industrial type of research has been carried out by the CSIR. CSIR-NISpR is among one of the labs of CSIR, and the basic mandate of this CSIR-NISpR is the popularization of the science. So how the or you can say inculcation of the scientific temper among the students, if we focus the students. Else, for the researchers, it is publishing around 18 research journals, and there are the 3 popular science magazines CSIR-NISpR is bringing out, which is for the students, they must have heard or they must have read. It's a Science Reporter, Vigyan Pragati and Science Ki Dunya in the 3 different languages, which is English, Hindi and Urdu. So these are the basic, the activities which CSIR-NISpR is carrying out. Apart from the other also activities, but for the students, these are the major ones. The Jigyasa, let me also come down to Jigyasa. Jigyasa is also one of the programs which started by CSIR in 2017 in collaboration with the Kendriya Vidyalaya Sangathan schools. And it was focused for these KV schools itself only. Later on, when the popularity and the need for the popularization of the science or the cultivation of the scientific temper among the students had grown, so it was thought that why not to extend it to Navodaya Vidyalaya schools also. So Navodaya Vidyalaya and all the state government schools. So this has quite extensively been extended to those schools also. Now the objective, what is the objective? The objective is basically that to train the students, to train the teachers so that they can, they can bring in the scientific temper, or they can bring in the attraction of the students towards the science stream. So this was the basic idea. And so the teachers can nurture the young minds also, particularly for the students. Because recently I had gone through one of the an article, not an article or a report in the newspaper, and I'd like to share with you also that in the Delhi University for the graduate courses, we had seen that the number of the seats in the different colleges of the Delhi University for the science stream was lying vacant, whereas all the other like commerce, then the humanities, all the seats has been filled. So again, it has come that we should work hard to see that why the students are not opting for the science stream. So maybe the reason that the science stream graduates or those who are pursuing the career in the science stream are not in a position to, to see, or they cannot foresee a good future into it, or they had not been, they had not been, they been told to them that what bright future does science stream also have. So this is also one of the reasons that we took up this webinar series. And in this webinar series, we wanted to just bring in, it can be treated as a success stories that what the different scientists are doing. And there is a very lucrative, the career ahead in the science stream also. And that is why we are bringing in every month, we are bringing in the notable scientists who are doing very good research in their respective domains. Like we had seen in the previous, we had taken up the road research, we have taken up the information about the earthquake, the research which is taking place into the geophysical sciences. So a different pattern that the students can able to see that yes, there is ample of opportunity to which exists in the science stream also. And I would also like this time, I would like to ask the students and the teachers also to please give the feedback also that some students and the teachers, they are continuously visiting our webinar or attending our webinar. So how much has it helped? The webinar series, how much has it helped in inculcating that scientific temper among the students? Just a thought that your feedback is very much required, the students and the teachers, because our efforts are only fruitful when we get a feedback that yes, something has improved. 0.1% if it has improved, that is benefit for the CSIR and for the Jigyasa team as well. So we, like earlier we had said, in the case of the Jigyasa also, we have the different models. The one model that we are following for the bringing the scientific temper among the students is like the webinar series that we are conducting. And as well, the different students in the different cities, if they can see that if any CSI lab is there, they can have a laboratory visit there under the Jigyasa scheme. The students and the teachers can visit there. And then the summer vacation, if you see that in your cities, if there is one of the lab, then the summer vacation programs can be taken place there. The student residential program can also be taken up. The visit of the scientist to the schools, if any school they wanted that, yes, our students should be benefited by having a lecture or by having a different activity, then they can approach to their CSI lab and ask them that under Jigyasa, the eminent scientist can come and can give a lecture to the students or can show any activity. So these are the different ways by which an interaction between the scientist and the teacher can take place. So sometimes the scientist can become a teacher and the teacher can also become a scientist. So these are all the different models by which the main focus is that yes, the student should also explore the science stream. They should also go to it. It's not that yes, in the applied and the other streams, the career exists. In science also the career exists, and it's a very much renowned work which can be done particularly for the country and for the nation. So I thank you, students, teachers, and as well the Dr. Shruti, to sparing time and has joined the webinar to deliver something, to bring out something to the students and the teachers. Thank you, Ms. Chen.
Thank you, sir. This is our 8th webinar, and it is on nutrition through grains. I hope you can see in all the slides, we have made sure to incorporate some grain in every slide. So Adarsh from our office has worked really hard to make sure that there is some grain represented in each of the slides. Very interesting topic, in my opinion. And of course, for all of those who are joining us online, the format of the webinar will be, we will be hearing from Dr. Shruti Pandey about the nutrition in grains. We will watch a video and we can then open the chat up for questions. So without further ado, we have our speaker today, Dr. Shruti Pandey, and I'm just going to quickly, just tell everybody about her fabulous accomplishments. We are truly pleased to welcome you, Dr. Shruti, who is a principal scientist working in Grain Science Technology Department of CSIR, Central Food Technological Research Institute. This is one of the premier institutions in India known for food technology related work, not just in India, but also abroad. Dr. Shruti has completed her PhD in food science and nutrition and has research experience in several fields. I'll say a few of those out: food fortification, product development, byproduct utilization, physicochemical, nutritional, functional, textural characteristics, and so on. She has also worked as principal investigator in 5-year institutional project and has helped to develop fortification technology for rice. That's a very interesting one, Dr. Shruti, if I may add. The technology on rice focused on addressing malnutrition by nutrient enhancement of iron and carotene in rice, its shelf life studies, retention of nutrients in the grains, and much, much more. Another technology that is being developed currently is the fortification of sugar with certain nutrients, which will help address the problem of malnutrition. And this is done by fortifying calcium and iron in sugar. Dr. Shruti has extensively worked on product development from food grains using pseudo cereals such as buckwheat and quinoa, shelf life analysis, and their scaling up. Right now, in fact, she is a faculty member as an associate professor under a CSIR. She's also a subject coordinator for MSc Food Tech, wherein she is guiding or has guided 18 MSc students and currently 2 PhD students. She's guiding them for completion of their PhD. She's got a total of 21 publications and she's a life member of 4 scientific societies. So Dr. Shruti, truly welcome to our webinar series. We are truly excited to have you join us and talk to us about nutrition through grains. I think everybody has heard enough of me. They'd want to hear from you. So welcome.
Thank you. Thank you. So can I share my slides now?
Absolutely. Please.
Okay, I think the slides are visible.
Yes.
Okay. So, in continuation with what Mrs. Jane has said and Sir from CSIR, I would like to thank National Institute of Science Communication, Policy Research and United Schools Organization for giving me an opportunity to showcase our work. And a lot of things Sir has already told about CSIR and how many CSIR labs are there. And of course, Mr. Jain has told about regarding what is the utility of such webinars. So I will not take much time on that. So just to start with the things, nutrition through grains. So I begin with just to give you a brief, like the contents of my what I will be presenting. I will be giving some introduction about our organization, then a brief introduction about cereals and grains, then the different processing methods and how you can minimize the nutrient loss during processing, which is very important. Those aspects I will be telling you. Then what are the different processings which are done to the grains that I will be taking up. Then few things like extrusion, cooking, fortification, supplementation, and some core areas on which I have worked and which are really of national importance and are being taken up at a global level also. I will be telling you about that. So to begin with, as you know that in continuation with whatever the earlier speakers have told, CSIR has 37 labs and CSIR-CFTRI is one of them. It is a constituent laboratory of CSIR and it came into existence in 1950. And we work on broadly around engineering sciences, technology development, translational research, food protection and safety, and human resource development. So these are the core departments, or you can say the main areas, broad areas under which we work. And then we also have a support departments, research centers at Hyderabad, Lucknow, and Mumbai. So that's how it is. And this is our beautiful mansion from where we operate. So it's a beautiful place, and of course, the mansion is very good. So that's how it goes. Now, coming on to the main topic on which I have to speak on. I am sure that all the students are at home or they are seeing the YouTube channel, and even the teachers all have taken their lunch. So I am very sure that everybody has eaten enough of grains, because grains constitute your main diet. Around 60% of the carbohydrate and the requirement comes through the grains and remaining from the pulses. So this is the major diet consumed thing in India, globally also. So as you all know that there are some major grains like paddy and wheat, which we eat on a regular basis. Then of course we have coarse cereals and grains also like sorghum, maize, barley and oats. And then we have millets, like which are called nutri-cereals, and like you have bajra, you have ragi, small millets, and then we have pseudo cereals like amaranth and buckwheat. So basically, what are grains? So as you know that grains are the harvested seeds of grasses like wheat, oats and rice, and they are basically, they belong to the class angiosperms, and it is like these are globally cultivated in arid region, in semi-arid region, and even in the marginal areas, and it is overall consumed by a majority of the population. So this is something like it is a main staple diet. It may be like some areas are consuming more of rice, some areas are consuming more of wheat, but overall the major diet focuses on these things. Then of course we have legumes, because as you know that all the nutrients are not supplied by cereals, so we have by these millets and other grains. So we have legumes also, which are major and minor. So again, there are different types of legumes which we consume on a day-to-day basis, like green gram, red gram, and then we have minor pulses also which we consume. So these are basic grains which we consume, and if you go by definition, grains commonly referred to as cereals or seeded grains, and they are the edible seeds of specific grasses which belong to the poaceae family. It is a small, hard, dry seed with or without an attached hull or fruit layer, harvested from human or animal consumption. So a grain crop is a grain producing plant. And if you see by the classification, if we go, it is like based on the cotyledons, it is divided like monocots and dicots. So monocots are having one cotyledon, example are cereals and millets, and whereas dicots have two cotyledons where you have legumes and pulses and pseudo-cereals. So one by one, I will be taking up these grains, and I will be telling you what are the nutrients and how it can be retained, how they are processed, and what are the different processing techniques which we apply for the grains. So basically, this I told you. Then we have millets, which are coarse grains, and these are also called nutri-cereals. And one thing very exciting, that next year is going to be the International Year of Millets. And now the focus is on millets because these are a stored with abundant nutrients, and till now they were not much explored or not much consumed because the major grains like wheat and rice were the maize. But now these things are also coming up, and they are largely grown in semi-arid and tropical regions and under rain-fed farming systems. And there are many core cereals like maize, sorghum, jute, oats, barley, pearl millet, and then minor millets like finger millet, kodo millet, proso millet, foxtail, barnyard, and so many. Then they are rich in dietary energy, vitamins, minerals, fibers, and phytochemicals and antioxidant property. And in view of these nutritional properties, these core cereals have also been called nutri-cereals, and regular consumption of that can save you from many chronic diseases. So these are the new food, or not even new, but they were old, but people were not knowing. So this is one good thing which I want to share, and many such things I will be discussing further also. And then to come to the other pseudo cereals. So pseudo is like, as you know, pseudo is something like what you say fake. So it is not actually a true cereal in a way that it is not a monocot. It is a dicot, but then also it behaves like a cereal, means you can pulverize it, you can powder it, and you can consume it. So that is how it goes about. And then we have pulses or legumes, which you all know that vegetarian source of protein. We always go for dals, and so many types of pulses we have. And these pulses we process and then we consume it. So with major pulses like Bengal gram, red gram, green gram, then we have minor pulses also. So these all pulses we consume on a day-to-day basis. So coming on to the nutrient composition, you can see that there are many millets which are rich in protein. Then even you can see in pearl millet you have fat also very high, and even in the little millet. And similarly, like finger millet is having a good source of calcium, and this calcium is quite bioavailable also. Even after cooking also, this is available to the body, which is a very important aspect of this. So this is a very good thing. Then even barnyard millet is high in iron. So all these are having inherent qualities of these are the inherent properties of these grains. So coming on to just to give you a brief introduction, as you all know, I started with all the grains. So first comes the wheat. Though India, many parts in India, we have wheat producing, and they consume a lot of wheat. And wheat basically is like, you have common wheat, you have Duran wheat. Duran wheat is like, which is used for the macaroni and pasta production. And then you have the common wheat, which is used for pulverized and used for like making atta. And then you also have like something like called maida. So as you know that all these grains, they have a certain structure in which they have endosperm, germ, and bran. So as they are polished, the bran layers are removed, and once the bran layers are removed, what you get is just the starchy endosperm, which they call it maida. So the atta is a more healthier form for consumption, and that is why, as you know, the wheat bread and wheat pasta, all these are also coming into a lot of work has been done into this context also, because a lot of people know that maida is or the refined flour is not a thing which has to be consumed in a large amount. So it contains a lot of starch and other carbohydrates, 11% of protein, 2% of fat, and fiber, and then many other minerals. And wheat germs are also rich source of vitamin E and enzymes. So whenever we process the wheat, we pass it through the roller mills, and the germ and the these things are separated, and the remaining it goes as the flour. So that is about the wheat. Now coming on to triticales. triticale is an artificially bred hybrid of two cereals, wheat and rye, which combines the features of both the species, and it contains protein 12% and about 55% carbohydrate, and it also has higher lysine content than wheat. And this is also one type of artificially which has been hybrid coming from the wheat and rye. Then, of course, we have rice, and as you know, rice is a staple crop, and it is consumed by a large segment of the population, and the Asian rice is called the Rhizos sativa, and the subspecies of that are Japonica and Indica. So Indica is common to India, and many of the types of rice are cultivated and eaten and processed in India. So if you see the rice around, there are 40,000 varieties of rice in India itself, and if you go globally, you have more than 1 lakh varieties, and it's really tremendous. A lot of varieties are there. So the rice is like you have red rice, you have black rice, you have many types of rice. So what basically when I say red rice means is the pericarp is red and it has many antioxidants and anthocyanin properties, and that is why that gives it a red color. Black rice, if you know, it is very common in northeastern part of the country. Chakhao is one variety, Kalabhat is one which is in West Bengal, and that there it is the pericarp is black, so it has a lot of anthocyanins and many other such properties which are of great importance. Now, one more thing what we understand in rice is that if you take rice overall, it is like something. When you process the rice, when you process the rice, what happens? You remove the bran layers. So even this red color rice, though some of the color goes off, but still you can, when you cook, you get that some of the anthocyanin contents. So here actually processing plays a role, and that I will be describing in detail when I come to the processing of this and how these things can be, in a simpler form, so that I think all the students can understand, because this is something for the students, so they should, understand. For that reason, I will make it more simpler, that how these things are done, so that it is easy and it comes into a nutrient form, and in the what you are getting on the table is really nutritive. So the other crop which is very much popular and which is even more cultivated globally, maize is the highest production of maize. Then only the wheat comes, and then comes the rice. So one of the reasons maize is a staple food across the world is its high nutritional value with high levels of starch and also valuable proteins and oils. And depending on the variety, maize may contain a number of important B vitamins, folic acid, vitamin C, and provitamin A. It is also rich in phosphorus, magnesium, manganese, zinc, copper, and so many other things. It is also a good source of dietary fiber and protein, and it is deficient in lysine and tryptophan, which are the essential amino acids. But overall, it can be mixed with other things and made into a more complete diet. So it has tremendous variation in content and composition, and there are many types of maize. You might have seen baby corn, sweet corn, and so many types of maize are there. And it is also very, notably the carotenoid, white beta carotene is converted into vitamin A, and this is a very good precursor for vitamin A. And as you all know, vitamin A is very much required for the human health, for the skin and for the eyes. So this is also a very major crop, and which is utilized in India and of course globally also, and many products are also made from that. Now coming on to the other one is the barley, which is used to obtain malt and the production of beer and for making porridge and for making burnt grain or many other things. And it contains 70% of the carbohydrate and 11% protein fiber. And the fiber in this is basically beta-glucan, which is a soluble fiber and which gives a lot of bulk to the diet and absorb. So this is actually eaten because of the fiber content which is present in that and the soluble fiber. So this is one of the crops which is also consumed. Now, I gave you an overview of most of the important crops which are grown, though there are many things which will come. And but what I want to focus here is we are eating many grains, and the basic purpose is you should eat all the grains which are locally grown in your area, which are processed in your area, so that those things are cultivated and they remain into that fashion. So the processing for each grain is different. Why it is different? Because each grain has a different structure. So what processing applies for rice cannot apply for maize, and what applies for maize cannot apply for dal. And once you have different sets of processing machines, so of course the losses also are different. So how do we minimize the loss so that we get the maximum nutrient retention and we can say that, yeah, what we are eating is healthy? That is our focus today. So just to give you that brief overview that how the grains look and how it happens, now I'm coming on to the main part, which is the processing part, and which we deal into that. So if you see the rice is processed by many ways. One is parboiling, then we have flaking, puffing, popping, size reduction. And if you come on to the products, so you have milled rice, flakes, popped, puffed rice, all these vermicelli and noodles which you get from these processing aspects. Similarly, for the wheat also we have milling, baking, extrusion, and then we get flour, atta, which is called atta, then maida, then suji, and many other bakery products. And for maize also we have dry and wet milling, and then we have with the products for this come out like popcorn, starch, brewery, and many other breakfast cereals. Then similarly for sorghum also we have popping and malting, and then we have roti, mudde, and many other malted grains, popped grains. Then similarly for oats and barley also it is flaking, malting, and brewing, and then we get flakes and brews, and similarly for small millets and so many other things. So basically the major processing steps which are done, because the grain is like that, it has an outer pericarp. Most of the grain structure is like they have an outer pericarp, and from that outer pericarp you have the bran layer, then inside is the starchy endosperm, and there is the germ inside. So what happens, whenever you harvest any grain, whenever it is harvested from the field and it is kept, like in the case of paddy, I can tell you, whenever it is harvested and kept and stacked into the field, because it is a live grain, it respires. So what happens when it is respiring, there can be something like, heat is being built up, and that can go, some fungal infection or something can come. So the basic concept, it starts from harvesting, is that you have to dry itself there itself. It should never be stacked and left in the field, because that is the crucial step. If at that step you just stack it up and leave it, what happens, there are a lot of respiration happening, so heat will be developing, and then fungal infection or yellowing of the grains can happen. So these type of grains, when it is subjected to the further milling, because they are not up to the mark, they subject to the breakage, and they don't give you the appropriate quality of the product. So basically, starting from the harvesting, one has to see this thing. So once the grains are harvested, the paddy is harvested, it goes for dehusking. And after dehusking, what you get is the brown rice. So brown rice basically, and how do we do this dehusking? It is generally done by the abrasive or the friction polisher. So abrasive, the polisher, sorry, not the polisher, it is the dehusker. So what we do, the dehusker is a rubber roller, and in which we pass the grains, and because of that moving force, the hull gets removed. So when the hull gets removed, what we get back is only the brown rice. Now this brown rice further is, subjected to milling, and this milling is done by these two types of polishers, like abrasive polisher and frictional polisher. So now the thing is, this here you have to see that how much polish you should give. The government of India has already fixed a level for polishing, so that if you polish too hard, if you polish too much, what happens? Your bran layers are removed. And once your bran layers are removed completely, it is completely mint white rice, which is nothing but just the endosperm. So of course you want something nutritious to eat. Either you can have directly the brown rice, which is of course a storehouse of many nutrients. It is having all the essential amino acids also. But if you are not able to eat that brown rice, because it is a little hard also to eat, and it doesn't give that taste what you eat as white rice, because we are addicted to white rice. So it has to be polished in a minimum way. At least 6 to 7% polish should be given to the rice, and it should not be more than that. Excessive whiteness will, when it comes to that, it is like it has been over polished, and what you are getting is just the starchy endosperm. So these are some of the things which, if somebody is into milling aspect or something, they should see that all these things have to be adhered to, and one should follow these norms. So these are the sets of machineries which are involved into that. But of course, it's a complex process, so you need not, you can just have a look. You can see that once the paddy comes, it has passed through the drum sieve and then through the vibratory sieves, destoner, all that impurities are removed, then the husk is removed. And then what we get after removing the husk is not that all the paddy is unshelled. There are some shelled also, so again it has to be separated and then polishing has to be done and then grading. So all that comes like that. So what we very easily go to the supermarket and buy white rice. This is all the steps which it undergoes to give you that product. So it is all this process which it undergoes. So it's a huge lot of things. So this is one of the thing of the paddy processing which I wanted to tell, and where we have to see that is the main thing is brown rice, how much polish you are giving. If it is excessive polish, it is just the starchy endosperm which one is consuming. So there we have to see how it is going about. Now coming on to the other part which we eat daily is the legumes. So legumes, you know, there are many legumes, major and minor, as I told you, small legumes, big, and all those things which we consume. Now, legumes also, you might have seen when, if you have seen how it is harvested and, you know, grown, it is not the way what we see in our table. It is different. So here also you have to process it. It undergoes processing. So there are two types of processing here also, wet conditioning and dry conditioning. So again, wet conditioning is a one process where you soak the pulse in water, you steep it in water, and then you dry it. So when you give this, you know, treatment like soaking and immediately drying and then tempering, so what happens? The husk of the pulse, it loosens up. And when this husk loosens up, then it is subjected to the dal milling machine. And when it goes for the milling, then it gets split up and the husk is removed. So that is called, you know, wet conditioning, how it goes about. Then the other process is dry conditioning of the pulses, in which we exactly do not soak it into the water. What we do is we just pass it through the milling machine and we develop some dents into the cracks into the dal, into the whole dal. And then what we do when we have those cracks or the dents, then the skin little bit loosens up. And then we smear oil. So this oil, you know, it penetrates inside and it separates the cotyledons from the husk. You know, and then what happens when this loosens up, then we pass it into the machine and it gets polished. So it gets splitted also. So some, like you have only split dal, some you have totally polished, the husk is totally removed. So these type of processing is done for the legumes. So this is the meaning of the wet and the dry milling, how you process. Then similarly you have maize milling also, where you have dry milling, where you are just subjecting the entire grains to the roller mill and you get all these parts. Then the other part is the wet milling, where it is like systematically done and you get many constituents like the starch, the protein, and all these are separated. So these type of milling are done for the maize. Then if you come on to the millets, so millets are basically very small grains, very small kernels. So there you have to go for a different set of processing machines, and you have to go for decortication and debranning of the grains, and then size reduction is done into the so that you get semolina, grits, and flour. And then similarly you have some of the pseudo cereals you have to do soaking, like in quinoa and even in this amaranth, you have to do the soaking to remove the saponins, and this is followed by abrasive polishing. So amaranth, I mean to say, is rajgir, and quinoa is of course a cereal which is like recently has come into the market, and other pseudo cereal is kutu, or you can say buckwheat. So this is also actually consumed, and all these pseudo cereals also have enough amount of starch. They have a very good source of starch also. That starch can be extracted also, and it can be utilized for many other purposes. Many industries also, they find their application. So, and moistening helps in the easy removal of the bran, but it causes breakage of endosperm and affects the keeping quality. So, in some of the millets also we do some hydrothermal treatment. And in fact, if I tell you, hydrothermal treatment is also known as parboiling, and parboiling is also done to rice. In fact, parboiling is done to the paddy. Paddy itself we parboil. We soak it in the hot water, and then the steam is passed. So what happens when you pass the steam, whatever cracks are there in that paddy, they get all healed and they are all closed. So such paddy, when you mill, you get 100% recovery. You get 100% recovery of the head rice. If you go to rice industry and you ask anybody, what is the USP in rice? So it is like how much head rice you are getting, the intact rice. So, and which is very essential for basmati and all, you know, the basmati is known for its length. The more lengthier the grain, the more popularity. So that is how it goes. So parboiling is also a very big, very easy treatment, and it has been done since ages. If you know, in Bengal they used to call it do bhapa, means it was parboiled twice, like heat treatment was done twice, soaking and steaming and like that. So same thing. Now improved versions have come, and you have many hydrothermal treatment plants also where parboiling of the paddy is done. And similarly, parboiling can be done for these grains also. Even in buckwheat, if you see, when we try to make buckwheat, if you want to dehusk the buckwheat, the kernel is very, you know, it is a aching type of structure. So the hull is very tightly closed to the grain. So what happens? You have to loosen that. For that reason, we do parboiling. So once you do that, and then we leave it for tempering. Tempering is also a very important step. Here, what happens? What happens when we give more moisture or when we parboil? Maybe the surface of the grain gets the moisture, but that moisture should penetrate inside. For that reason, we do tempering. So tempering is nothing but heaping the crop, heaping the grain, and keeping it at one place. So the uniformity of the temperature is there. Whatever moisture is at the top also should be in the inside, in the core of the grain. That is why we go for tempering. So these are some basic, you know, processing methods like parboiling, tempering, which we do for the grains on a day-to-day basis, so that you get a better finished product, and most of at least the nutrients wise also it remains quite rich. So that is about the millet milling. Now one more process is there which is done, and which I am sure many of you are eating, this kurkure and all these things. So these are extruded foods, or this what do you say in the morning, Kellogg's and all that stuff. So these are actually extruded foods, and food extrusion processing is a process in which a combination of food ingredients such as maize, soy, wheat, sorghum and many others are forced to flow under pressure through several conditions of mixing, heat application and shear through a perforated plate or die with a design specific to the food that is being shaped with desired ingredients. So this extrusion process formulates a new cooked food products loaded with intended nutrients. And during extrusion, thermal and shear energies are applied to raw food materials, causing structural, chemical, and nutritional transformations such as starch gelatinization, degradation, protein denaturization, and lipid oxidation. And many other changes happen. So that is how your extruded food goes. And there are two types of extrusion, hot and cold. So hot extrusion is actually high temperature, short time treatment. The temperature is quite high, and that is given for a short time, and then a small die and shear pressure and temperature is given, and then it is extruded through that die in whatever shape you require. That is hot extrusion. And cold extrusion is done at room temperature, and mostly, like if you have seen noodles and pasta and all that, is the application of your cold extrusion. So that is how it goes about. And now another way of making the food rich in nutrient, or grains are rich in many nutrients, but what happens, all the essential amino acids are not present in all the grains. So what we do is we mix and match, we mix dal with rice, we mix this with this, so that our amino acid profile, it's complete, amino acid picture gets completed. So another way to enrich, or you can say to increase the nutrient content of the grain is by fortification. And what is fortification? It is nothing but it is the addition of one or more essential nutrients to a food, whether or not it is normally contained in the food for the purpose of preventing or correcting a demonstrated deficiency of one or more nutrients in the population or specific population groups. So food fortification is like basically that nutrient may or may not be present in the food. It may not be present. Basically, generally, it is not present, but you just add for a larger cause, for preventing some nutritional deficiency which is existing in a mass population. So the public health benefits of fortification may either be demonstrable or indicated. And it is basically done to prevent or minimize the risk of occurrence of micronutrient deficiency. Then, and then it is done to the contribution to the correction of the demonstrated micronutrient deficiency in a population, to correct any deficiencies which is already existing, and for an improvement in the nutritional status, and overall to give a consistent micronutrient delivery or improving the health of the overall population. These are the main accepted scientific reasons why fortification is done. So there are few terms which are interchangeably used with fortification. One is restoration. So restoration is something like where already the nutrient was there, but during processing it got lost, like vitamin C in fruit juice, and because of that reason you try to restore it back once the final product is made. That is restoration. So it can be defined as the replacement of nutrients lost during processing to levels similar to those present in the original products. Then the other one is enrichment. This is a term often interchangeably used with fortification, and it is the addition of nutrients to achieve concentration specified in standards of identity. Sometimes what happens, you might have seen Horlicks has to be enriched with something because that is the mandate, or it has been prescribed. So that is enrichment. Then you have supplementation, wherein the government, sometimes you might have seen in Anganwadis and all, they supplement tablets or iron and folic acid medicines, because that is externally they are giving a medicine or a tablet or vitamins because the population is lacking that. So that is supplementation. Now, if you want to fortify, what is the basic thing which we require? What we require is in which food we should fortify, because the selection of the food vehicle is very important. Why it plays a major role is, suppose in our country we are eating rice on a regular basis or wheat. So we fortify wheat because at least 2 or 3 times a day we are eating, and we are eating in a regular amount. So that is why the selection of food vehicle is very important. Now in countries like Malaysia or some other countries where I came across studies, they have fortified soya sauce because they might be consuming that in large quantities on a day-to-day basis. So like that, the selection of the food vehicle will vary which region, which country, and what is the mass population eating. So what are the important points we should keep in mind? They are consumed by a large population, they are consumed on a regular basis, and it should be such which can be centrally processed. This is very important. If something is already a system exists of rice milling and parboiling, and in that plant itself we can do the fortification, this will be easy rather than starting something new. So something which is already existing, there only we need to add few machineries and we can do the processing. So that is why this is also very important. And whatever you want to fortify any rice or whatever, it should be stable, because if we fortify and it is not stable, then we are not going to get the nutrients. So this is very important in the case of fortification, how it goes. Okay. Now selection of the fortificant. Now once we have focused on what we have to fortify, the second thing we have to see is which nutrient we should add. So this is also very important, because if you don't add a proper nutrient or a fortificant, then the fortification process, the whole work will fail. The fortificant should be such which should not develop any color when mixed with the vehicle, and it should be well absorbed within a meal, and it must not impart any color, and it should be stable during transportation. So these are the few things which we have to keep in mind when we fortify something with a particular nutrient. Because if it is giving now suppose you get iodized salt in the market and you bring that salt, and when you sprinkle it on your salad or something, it starts giving a purple color or a yellow color, that nobody is going to accept it. So it should not impart any off taste or off color to the finished product. That is one important thing. Now, if you see, there are many types of fortification. We have mass fortification, which is done basically, mass fortification, which is like you have iodine fortified salt, and also these programs were basically instigated, mandated and regulated by Government of India. They had started this program for preventing deficiency which was in the mass population. Maybe in the Terai region that time iodine was not there in the soil and they were having iodine deficiency or vitamin A deficiency or whatsoever. Then there are few cases in which targeted fortification are there. We see in a certain area only this, like in certain areas we have certain deficiencies. So for that particular area, we have targeted fortification or that particular vulnerable group. It can be to a group also, like what do you say, the teenage girls or something, iron fortification for them. So that will be targeted for that particular group who is more vulnerable. Then you have market-driven fortification. So market-driven is like now many, you can see that many industries have also come up. Like recently you might have seen Tata with double fortified salt, iron and iodine. So sometimes these corporate people also come up because of some social responsibilities. They also come up with some fortification programs. So that is how you have market-driven fortification also. Then you have community-driven fortification. Like I came across some reports where in Gujarat they were having a community-driven fortification. So wherever they used to, pulverize the floor, they used to mix a sachet of some nutrient fortification which was given to them. So that is community-driven. At the village level, somebody is taking it up. Then you have biofortification. Of course, this you might have known also. Like you have the golden rice where the genes transplanted, and that is done. So this is an example of biofortification, and it produces beta carotene in the leaves but not in the grains. So in this, the golden rice, 2 genes have been inserted into the rice genome by genetic engineering, and this type of rice, the picture you can see how yellow it comes out. So that is the golden rice which is done by biosynthesis. But of course, all these things have their own implications. So what we have worked also, worked on fortification and many other things. And globally also, this has been done on a very worldwide basis. Since ages it has been done, and successful longitudinal studies have been done, and results have come also. Like salt iodization was started in Switzerland and United States, and then from 1940s onwards, thiamin and riboflavin and margarine was fortified with vitamin A in Denmark, and milk with vitamin D. And then foods for young children were fortified with iron and folic acid and such things. So that is how it came up. Then more recently, America has, and even Latin American countries are also going for grain fortification, and many such programs are being run at a different countries at different levels. So now, if you see the fortified logo, what we have on the salt is like this, and what FSSI has given for this fortification is F plus. That means at least 3 nutrients you should have at least minimum to get this logo on your food packets. So that is how it goes about. And if you see on the national level, in 2016, multiple stakeholders led by Food Safety Standards Authority of India, they issued a joint declaration noting that food fortification is a realistic and sustainable complementary strategy to food fortification and dietary diversification. So many of the guidelines had come that time for the food fortification and how the fortification should be done, in which grain you can add which of the nutrients. All these things had come up, and that clarity we got from FSSI. And in Gujarat, the government had initiated an Antodaya scheme under which fortified wheat flour was given through public distribution system. And similarly, in Haryana state, also fortified atta was given, and many other such things are being done. Then in Tata Trust also came up with this double fortified salt, and then in India, a globally recognized GAIN, they had taken up fortification program in Madhya Pradesh. So they have also come up with fortified products. That is the ultra rice, which they came up with the ultra rice, which is actually a grain which has been. It looks like a rice kernel only, but it is actually an extruded product from many of the nutrients and rice flour, which is mixed together, and then it is extruded, and then this rice grain is mixed with the normal rice in a certain ratio, and that is called as ultra rice. So if you see in Karnataka, of course, we have Anna Bhagya scheme, under which Karnataka government distributes food grains and oils to the children. And then we have Shira Bhagya scheme, under which 64 lakh students studying in many schools, they are getting milk. And then we have Karnataka Health Promotion Trust. And then there are many other such schemes which are going in the state also and at a national level also. And then coming on to the products which are available in the market, you can see a variety of products are there in the market also, and which also carry the logo of fortified fortified logo which has been given by FSSI. So many such foods are there in the market. Now, what initiatives we have done, we have also developed a protocol for fortification of rice with iron and carotene and folic acid, and we also have worked on sugar with iron and calcium. And these were some of my results which we had worked, and we had seen that we had developed a different method altogether. It was not by extrusion, it was an imbibition method which we had developed for the carotene, and we could find that at least the contribution 100 grams of the cooked rice contributed to at least 17 to 25% of the RDA, and which is quite a good, and cooked 100 grams of the rice also provided around 50% of the iron RDA. So this was something which was like even after cooking also we had done, and we had seen the losses were minimum, and even the bioavailability also we had checked that aspect. So that is how we had done the fortification by imbibition method, so which is more cheaper and which is more eco-friendly like that. And then we had double fortified. So double fortified is nothing but when you fortify two salts together, like iron and carotene, or iron, carotene and like some others. So that is double fortified, carotene or folic acid, something like that. So this work also we had done, and in that we had seen that cooked form of contributed to 42% of the RDA, and RDA is nothing but the recommended dietary allowances which should be met if you are taking any particular nutrient. For every nutrient there is a recommended dietary allowance which you have to take each day according to your working status. It has been mentioned like sedentary worker or heavy worker, like that the RDA has been given for each nutrient. So these were some of the things which we have done, and the pictures I would like to show how it looked, the carotene rice and the parboiled rice. Different processing also we had done, in the parboiled form also, and even in the raw form also, without parboiling also, how it comes. So these are some of the pictures and how it looks on after cooking. So these were the pictures how it used to look after cooking, and some yellowishness or the yellow color was there in the carotene one, and which was not an off color, which was very pleasing also. So these are some of the things which we had done, and you can see how the grains looked quite intact also, even after cooking, and there was no off taste or anything in those, and they had a shelf stability for 3 months. And then we had also tried out with folic acid, and that also we had seen, still the work is in progress. And then we have some multi-grain food products also here, which CFTRI has developed. And because we focus on whole grains, so whole grains of multiple grains is good for health and wellness. So sorghum, pearl millet, ragi, wheat, maize, and all these contains nutraceuticals and has high vitamin E activity, antioxidant activity. So all these foods also we have developed from the different millets and grains. Then we had fortification of sugar also. Here also this was a project actually, and here we had tried to develop by fortifying with calcium and iron as the requirement of the company, and it was given to them. So it was a kind of SSP project which we did for them. Then we have many other technologies which we have fortified atta, then we have fortified protein rich vermicelli and whole wheat pasta, biscuits, protein rusk and pashtik atta. So these are some of the things which we have done and which are coming up in the market also. Now if you see the advantages of fortification, of course there are many. If consumed on a regular and frequent basis, it can maintain body stores of nutrients more efficiently and more effectively. Then fortified foods are also better at lowering the risk of multiple deficiencies that can result from seasonal deficits in the food supply. Then it is an important advantage to growing children who need a sustained supply of micronutrients. So this is very important here. And then fortification does not require any alteration in food habits. Whatever food we are eating, that only has to be added with certain nutrients, so you are not changing any food habit of yours. And when properly regulated fortification, it carries a minimum risk of toxicity. If it has been all done properly, there is minimum risk of toxicity. And it is more cost effective than any other strategies which the government has implemented. So this is one very good thing to increase your nutrient level and to get a regular supply, wherein certain areas like which are in snow laden and all, where you don't get green vegetables. If you have something like carotene rich rice or something which you get on a regular basis in Anganwadi or something, it is a good meal. Then if you see the limitations, of course everything has limitations. So fortified foods contain increased amount of selected nutrients, and they cannot be a good substitute for a quality diet. So of course you can eat all these foods also, but a regular supply of good and fresh fruits, seasonal vegetables, seasonal grains is very important. And then the children or the young children who eat little, their kind of aspect also, we need to see how much micronutrients they are intaking or how much they are eating. And then all those technological issues should be resolved. Once we are into that, there should be no such off taste or anything, or consumer preferences should be taken into mind. And the nature of the food vehicle and all also play a role, so that also we need to see. So these are some of the limitations, but in spite of these limitations, it is a very powerful tool to address malnutrition, to settle down all the major problems which happen due to the low availability of fresh foods or something, at least for the time being. That can be taken it up in that way. And of course, we need a lot of political support, industry, adequate legislations, which of course FSSI has provided, consumer acceptance, and all these things are required. And we should also always see that what you are adding should be something which is not, and because we are adding it into the food, into the basic grains, it should not be something which is of animal origin and you add it to the rice or to the wheat. It can be chemically synthesized. That is okay, but it shouldn't become from an animal origin, because again you need to give a brown logo there. So that type of thing shouldn't be carried out. So these are a few things which one should see for a successful fortification program and how to do it. And overall, as I can tell you, to conclude, I can say that all the grains should be consumed which are locally cultivated and harvested, and minimum polishing should be done to the grains in order to get the maximum nutrients. So the polishing always, as I told you, because once you polish, you are removing the bran layers, and the bran layers only have the maximum nutrients. So minimum polishing should be given, and processed food should be consumed least, and focus should be given to healthy and nutritious food. Healthy snacking habit also has to be developed. Snacking is also part of the meal only nowadays, because everybody has habit is there of snacking in between. But then we should try to focus on the healthy snacking. And if you see, it is not that we don't have healthy snacks. We have popped grains, we have puffed grains, and we have certain grains where they are just minimally processed, so that you can and whole grain are there, which are minimally processed, so that you get all the nutrients. And the labels on the food items also should be read very carefully, because there are many false claims also which are made, and we should try to understand the labels also, and then only we should go for purchasing such items. So all what I can say is, in a nutshell, I described there are many things into that, but of course a little bit complex also at times, but I wanted to assure that all the students understand this thing, that whatever you are eating, one has to see that it is minimally processed, and it is not that many preservatives or additives are added. If you consume whole grains, if you consume the whole grains, it will give you maximum nutrients, and that is what we should focus on. So this is something which I would like to share, and to end with this quote, I really liked it, and I think we should focus here only. So that's all for today, and now I would like to show you my video. One video also I had prepared, and this video.
Dr. Swati, is the video playing? We're not able to see the video. Dr. Shruti, is the video playing?
Yeah, ma'am. Can you see the video?
No, the video, we are not able to see it. We are seeing you, your image, but not the video.
Okay, just a minute. Can you see it now?
No, the video is not playing, Dr. Shruti.
Okay, just a minute.
Yeah.
They cannot see the video, though I tried. I played. Yes, no, I played, but they are not. Can we try it again once? Yes, you can. This one, this will look you this. Come here. Click. Stop sharing. And also okay. Click. Just a moment. It was visible that. Yeah, just. Ma'am, can you see it now? Hello? Ma'am,
No,
you cannot see the
nothing.
video?
It is blank screen for me.
Okay.
I'm assuming it's the same with everybody else.
Okay, we'll try once again. Okay. One minute. Video share ಆಗ್ತಾ Ma'am, are you able to see the video?
Yes, we can see the video, but there's no sound.
That problem is there. Oh yeah, that will be there. ಈ ತರ ಶೇರ್ ಮಾಡುವಾಗ ಸ್ವಲ್ಪ ಹೊತ್ತು ಪ್ಲೇ ಆದ್ರೆ ಬರುತ್ತೆ ನೋಡೋಣ. No, that is a normal. This we have. Your face earlier also.
Dr. Shruti?
Ma'am, we are trying. You just wait for few seconds.
Sure.
You're able to now get the audio, ma'am?
The video is playing, yes, when you played it, but there's no sound to the video.
Okay, ma'am, can you play? I have given you the control.
Oh, I can play it, but I don't know if I can. I think the video is playing, but there's no sound still coming. No problem. What we'll do, Dr. Shruti, is if you could kindly share the link of this video, we will share it with the teachers who are here. I think there's some setting, if it is on PowerPoint, some setting needs to be done in order for this to, the volume needs to come by. So we'll probably, if you can share the video with us, we'll pass it on to the teachers.
Okay, so I'll share the video.
Yeah, you said Google Drive. Google Drive.
Okay, I'll send it through Google Drive, ma'am.
Sure. That would be great. And we'll share it with all the teachers and students who are attending today.
I'll
So
share
just,
Google Drive.
right. Fine, doctor. So before we conclude, just want to open the floor up for questions. I think somebody has their hands up. The chat box is open, so thank you. We are getting comments as well. This webinar was very nice. So Dr. Shruti, that's for you. Any other questions that anyone has, please ask the questions now in the chat box. So I'll start with the questioning, Dr. Shruti. One of the things is we went through the entire presentation wherein you spoke about fortification as well and all the grains. I mean, just to ask you quite in a very open way, which is the best atta that we should be taking for rotis?
Actually, if I tell you that way, you know what they are telling. I always feel that fresh, what you get in when you give the wheat and they pulverize it, that is always better than these packed ones. Okay, because they can be old also, they can be old lot also, and then second thing is they also add maybe certain preservatives. So I feel the freshly where it is getting pulverized, that is the better. And of course, if you can make it multigrain from your side only, like you can add certain more barley or something, and then it can be pulverized. So that is the best, I think. But of course, what ITC, fortified atta and all they are coming in the market are also one way good in a way that you are getting certain added nutrients into it. So that is not, that I'm not, means I cannot deny also, of course it's a good thing. But if you have access to a fresh thing, why, if you get fresh cherry or something, why do you want to go for processed? So that's always there, I guess. But of course, these fortified things also, and if through ITC or some big companies, they are maintaining their standards and they are maintaining whatever the whatever claims they are making, then of course that is also good, like fortified atta and all to the people who cannot go and get it done. So of course that's an alternative, and at least you are having that, what do you say, legacy of going and getting it. At least that is there, ready in the market. So that is one thing which I can say.
Yeah. Nice. And okay, we have another comment from Ms. Madhu Batla who's saying very nice webinar. So that's very nice of you. Thank you. Any questions that you all have? If you like, the chat is open and you can ask those questions. I think someone has raised their hand. Okay. Ms. Rijma Pathan, you've raised your hand. Could you kindly type your question in the chat box if you have a question? Okay. I think that's all that there is, but I think this was a very valuable session because we deal with grains on a daily basis. We put grains inside our body as well, so it's very important to know which one is more nutritious, which one has what nutrient content, what does fortified mean, and so on. The advertisements on TV always says these are fortified, but now we actually know what fortified means. This had become a term which was in used so often. So thank you so much, Dr. Shruti, for your time and for sharing the valuable insights. As I always say, science is everywhere around us, and no doubt it is food that we eat, and this is a type of science as well. So not just having understood and known about all of these scientific terms, but it's also important for us to absorb it in our daily lives. I hope this also ignites some interest in science and certain fields among the students. For all the teachers, really requesting you to share this information and knowledge with the students as well. So before we conclude, just want to mention that our next webinar, which will be webinar number 9, is scheduled for 30th of December, last webinar for 2022, and very close to the new year as well. Again, on the last Friday in the month of December, and it will be at 4:30 p.m. Details of that we'll share later as we normally do. So since there's no other question and there's nothing else, thank you very much for all those who are joining us, the teachers and the students, thank you. And Dr. Shruti, truly thank you from the bottom of our hearts for this wonderful webinar and the presentation. We'll look forward to receiving the link of the video, and then we'll share it with everyone.
Yeah. I'll mail you, ma'am, and I will share.
Yes.
Actually, it was running very well. I don't know now that some glitch happened and they tried to help me out. So I'll share the link.
Yeah, no worries, no worries. This happens, technology sometimes, as much as we use it, there might be a small setting which if we haven't checked or ticked, we never know. So no worries, we'll share it with the teachers who joined us and even others. But thank you so much. Have a great evening. And maybe next time you can give us the name of those brands as well of the atta and the chawal.
Okay, that can be done. Okay, thank you.
All right. Thank you so much. Have a great evening, everybody. Thank you, Dr. Shruti, once again. Thank you.
Thank you.